Use matrix inverses to solve equations where the things in the equation aren't numbers but matrices. Now this will be an abstract kind of job, but we will move on to applications. So if you look at this equation, the question is, how do you solve, say, 5x equal to 2? Now for a start, as soon as you say stuff like move, you're talking nonsense. And that's not what mathematics is. So the natural way, I would say, is that I'll do it quite slowly here. Is that we divide both sides by 5. Actually, yeah. So if you divide both sides by 5, on the left hand side you have 5 multiplied by x, and dividing by 5 undoes the multiplication by 5, and you're just left with x, and you get x equal to 2/5. So what did you do? You divided both sides by 5. Okay, now division itself can be defined in terms of multiplication. So instead what you can do is you can multiply both sides by 1/5. So you have 5x is equal to 2, and rather than saying, oh, I will divide by 5, you can say I will multiply by 1/5. Now actually one thing we should say is just some very, very basic theory of equations. What does this equals mean? It means that these two things in the blue circles are the same thing. And if you take two numbers, 5x and 2, and do the same thing to both of them, you will end up with two new numbers that will still be equal. So 5x and 2 are the same thing. Divide them both by 5, you get two new numbers, x and 2/5, that are also equal. So you end up with x is 2/5. Okay. So similar story here, we're going to multiply both sides of this equation by 1/5. And so say I multiply the left of the equation by 1/5. So that'll be 1/5 times 5x equal to 2 by 1/5. Now we'll come back to this something a bit later, but for now, happy out. And now we can actually take extra lines here if we want. So one thing we can do is we can say 1/5 of 5 is 1. So you get 1x. Now 2 by 1/5 is what we call 2/5. And then you can say 1 by x is x. Now it's kind of an overkill, but it's actually what's going on here. Well, you can say you can say the 5th by 5 is 1 and 1 by x is x. Or else you can just say that multiplying by 1/5 is the inverse of multiplying by 5. And you don't have to go through the number 1, but it doesn't really matter. Okay, so this number 1/5 is known as the multiplicative inverse of the real number 5. So what you have is you can define, if you want to divide by 5, that's the same as multiplying by 1/5. It's the same thing, which is the inverse of multiplying by 5. So dividing by 5 essentially is the same as multiplying by 1/5. This x with the little numbers means x multiplied by this. The dividing with the little number means divided by 5. So dividing by 5 is actually multiplying by 1/5. And then what is 1/5, or what is multiplying by 1/5, which is kind of the same question. It's the inverse of multiplying by 5. So that's what a fifth is. It undoes a multiplying by 5 essentially. So suppose that you have A and B are two known matrices. Okay, now we need to look at two possibilities here. AX is equal to B and XA is equal to B. And these are going to be different things. Okay, so what you'll say looking at the AX equal to B, what you're going to do is, and there's two ways we can do it. So we can kind of go, we can go straight from here to, well, it's hard to pick which one. Okay, we'll forget about that. Okay, so essentially what you want to do, you're looking for the matrix X. You want to get rid of this multiplied by A. Now here you don't have division by A anymore. it's dangerous, as we explained. Are you dividing on the left or dividing on the right? If you want to use that language, you can, but I think you're kind of getting into a world of pain. I think it's just easier to kind of forget about division altogether. Forget about division, talk about multiplying by an inverse. So you want to get rid of that a, you have to multiply here by a inverse. So if you want to get rid of that a, you multiply it by a inverse. Now what you must do is you start with two matrices that are equal, and you can do the same thing to both of them. Now, as we argued in a previous lecture, multiplying on the left is different to multiplying on the right. Now, what I mean by the left and the right is, I don't mean left and right, I mean left of ax and right of ax, or left of b and right of b. So to get rid of the a here, you have to multiply by a inverse on the left. Multiplying by a inverse on the right, essentially, so let me just look at that for a second. Suppose if you have ax, a inverse, can this a get at that a? The answer is no, because for that to happen, you'd have to be able to swap x and a inverse. But that would be to say that the order of multiplication of x and a inverse, the order of multiplication of two matrices wouldn't matter, but it does. So instead what you kind of have is this kind of hold me back situation where it doesn't work. Now, technically you could take ax equal to b and multiply both sides by a inverse on the right, but you're not going to get rid of the a. You have to multiply by a inverse on the left. And if you multiply by a inverse on the left to ax, you must multiply by a inverse on the left to b as well. Now, see up here with the numbers, we multiplied on the left here and on the right here, but with numbers, multiplying by, say, 1/5 on the left is the same as multiplying by 1/5 on the right, because with numbers the order of multiplication doesn't matter. 6 by 7 is the same as 7 by 6, but that's not the case for matrices. Now what we do is the a inverse undoes the a. Now if you want, you can call this an ix and then say ix is x, and you end up with x equal this, but I think it's probably just easier to say a inverse undoes the a, so you end up with x is equal to a inverse b. Now, in contrast, with xa equal to b, you need to multiply both matrices with a inverse on the right. And you can't do, say, a inverse here and then get a inverse b. Both of them have to be on the right. And so in this one, you get that the answer is, so the a inverse undoes the a, x is equal to ba inverse, which is a different thing. The crucial difference between a matrix equation and a real number equation is that the order of multiplication matters. So AB is not necessarily equal to BA. Now, occasionally they are, but in general, you assume they're not. Hence, we must multiply both sides on the right or both sides on the left. So both sides on the right is here, or both sides on the left is here. You can't mix and match, because then you're not doing the same thing to both sides. Okay, do one example of this. So we've got xa equal to c. Now I'll just do one extra line here that you can include if you want. So look, well, I suppose we'll do the easy way first. So we have xa equal to c, and we're trying to find the matrix x. We know the matrix says a and c, so what we have to do is get rid of that a on the left hand side. So you need to multiply by a inverse here. Multiplying by a inverse here is no good. Have to multiply by a inverse here. So we're multiplying by a inverse on the right. We have to do it to both sides. I'll write this little arrow yoke here. This is saying if this is true, then this is true. And then what we can say is that a inverse undoes the action of a, so you're just left with x. So x is ca inverse. Now there is, you can, if you want, you can do a little bit extra. We'll just write it down here. So you can do XA equal to C. Therefore, XA A inverse, multiplying on the right, equals to CA inverse. Therefore, A by A inverse is equal to the identity. So XI is equal to CA inverse. And then X by the identity is just XX is equal to say CA inverse. Now, actually, that's how I used to do it. But I think it's easier just to go straight from here to here and skip this line. But if you want to include it to help you understand. So you might, like, to me, the inverse is undoing something, that's no problem. But if for you, the inverse is like making like a kind of like a number one. So it's like matrix A by its inverse is like the number one, then this would be the more natural way of doing it. Okay, so at any rate, we need to find A inverse, and I'll just check. Yeah, we're going to be doing more multiplying up there. So let me write down again the formula for the inverse of a matrix, 2 by 2 matrix. A, B, C, D inverse is equal to 1 over right down diagonal minus left down diagonal. You swap the things on the right down diagonal, so instead of A and D, it's D and A, and you change the signs on the left down diagonal. Therefore, now you can label these things in A with A, B, C, D if you want, and that's fine. So maybe I'll do that here. It's not how I would do it, but maybe it helps you. So I wouldn't do it, but look, let's do it here. So we're saying, look at the pattern. So the 1 is the A, the minus 3 is the B, the 4 is the C, and the D is the 6. So I'm going to kind of carefully, the way to, of course, get used to this formula is to do a few exercises, and you get used to the formula. So it's equal to 1 over AD. So AD is 1 by 6. For me, the right down diagonal. Take away BC, which is minus 3 by 4, which for me is the left down diagonal. And look what the formula says, it's D and A. Let's just do D up in the top left corner. So the D is 6. Let's do minus B. So that'll be minus 3. Then minus C. The C is 4. So minus C is minus 4. And then A, finally, A is 1. So that's kind of using the formula very literally. Then the thing on the bottom is, it looks like to me, minus 3 by 4 is minus 12. So you got a minus 12 situation. That's a plus 12. So I got 6 plus 12 is 1 over 18. And then this bit of it is 6 minus 3 is plus 3, minus 4, and 1. And I'm looking for X, which is, remember you can pause this, C by A inverse. I've got, this is A inverse. And I need to multiply it by C on the left. Now I'm going to just pause to write down these. So I've just written them down now. So our algebra has shown that X is CA inverse. So X is equal to C. So C is 16, 32, 36, 84. And A inverse is 1/18, 6, 3, minus 4, 1. Now, this looks a bit weird because we have a matrix, a number, and a matrix. Now, there's a bad choice here. The bad choice is to multiply in the 1/18 into this, and then we'll be multiplying by kind of nasty numbers. What's better is to know that the order of multiplication of numbers and matrices doesn't matter. So if K is a number and M a matrix, then Km is the same as Mk. Now, Mk, we haven't necessarily shown that, but you can show that this is the same as M times K times the identity. And that's the sense in which number by matrix is the same as matrix by number. That's kind of what's going on in the background. Because what you have is, how would you show that? Yeah, with a bit of work, but they are basically the same. So what I'm saying is we can swap this and this. and then multiply it in the 1/18 at the very end, or keep it out if we want as well. So I got 1/18. So I'm swapping. So order multiplication of matrices matters, but matrices and numbers, multiplying matrices by numbers, the order doesn't matter. You get the same thing. So as usual, let's look at the sizes of these matrices. So this is a 2 by 2, and this is a 2 by 2. Those middle numbers do match. The outside numbers are 2 and 2, so we're going to get it out of 2 by 2, but remember we also have the 1/18 knocking around, which we'll deal with at the end. So we're going to get a 2 by 2 as we said. I might have to go and look at the calculator. We'll see how we get on, see how tired I am. So top left hand corner is row 1 by column 1. So 16 by 6 is 96. Plus 32 by -4, which is 128. Next one is row 1, column 2, 16 by 3 is 48. Plus 32 by 1 is 32. Then we have 36 by 6, which is 216. Plus 84 by -4, what would that be? That'd be minus 332 or something. Let me just check that. 84 by 4. 336, close. Then the next one, 36 by 3 is 108. Plus 84 by 1 is plus 84. So we'll tidy this up. I get 1/18. 96 minus 128, I guess, is minus 32. 48 plus 32, I guess, is 80. 216 minus 336, I guess, is minus 120. And 108 plus 84 looks like 192. And you probably could leave your answer like that, but we'll multiply in the 1/18. Now, I will actually use a calculator here. So if I do minus 32 by 1/18, I'll get minus 16 over 9. It's kind of a bit funny. Okay, so we're back. So the 1/18 by minus 32 will give you minus 16 over 9. The 1/18 by 80 will give you 40 over 9. The minus 120 by 1/18 will give you minus 60 over 9, which I think you can do a bit more of it. That'd be minus 20 over 9. Excuse me, over 3. And the 192 divided by 18, I will use the calculator. I get 32 over 3. So this is a matrix that we've found that has the property that if we do that matrix we just found times A, we get C. Okay, now that's a kind of a totally abstract thing and you're like, why are we doing this? We will see applications next week.